Hello everybody, my name is Mike Geig and welcome to another live presentation on Unity. How's everyone doing today? Hopefully fantastic, because I'm not going to wait around for you to type in chat. So today we are talking about light, and of course before I get in all that, I've got to do my traditional plug here. If you have any questions, comments, you just want to say hi or chat or hang out or whatever, you can reach us on Twitter at Unity3D, at Mike Geig, which is me, at Will Goldstone, and at The Ant Ranch. You can also follow us on Facebook and apparently on LinkedIn. I didn't know that. I just learned today that we are also on LinkedIn and Google Plus and a bunch of other stuff. So there you go. Didn't know that. So if you want to reach us, it's not hard to do. We are fairly available. So again, that's us. If you have any questions, comments, conversation topics, whatever, feel free to reach out. All right. Now that that little plug is out of the way, real quick, if you're having difficulty seeing the stream or if you can't see it at all, refresh the page. Sometimes it takes a second for it to flip over and start the live stream, and you might need to refresh. So there's that. If anyone else says it during the presentation, just let them know. That's what's going on. All right, so last week we talked about cameras, so this week it's pretty fitting to talk about light because they kind of go a little hand in hand in how things are seen in your scene, I guess. So basically, when working with light, there's a lot of different systems that are in play across a lot of different game engines. So every game engine kind of handles light a little bit differently, and they use different built-in systems and stuff like that. So what we're going to talk about is we're going to talk about Unity's way of dealing with light, and we're going to talk about how some of this stuff is calculated and what the different types of light are. I see a question here, will there be shadows? Yes, we'll talk about shadows, and we will see all that stuff. So let's go ahead and hop right in. So basically, there are a bunch of different types of lights, but there are three that we're primarily going to use, okay? And those three are point light, which is basically like a light bulb, projects light in a total 360-degree arc, projects light in every direction. We also have the spotlight, which works kind of like a flashlight or an actual spotlight or anything of that nature. And then we have the directional light, and we've used directional lights before. And directional lights are infinitely away, infinitely parallel lines of light that illuminate an entire scene evenly. We use those whenever we want like a sun or anything like that, right? So those are kind of the three types of lights, and there are some honorable mentions which I'll mention now. We may look at, we may not, it all depends on the time and stuff like that, but they're not really as important. And so what we have as our honorable mentions is we have self-illuminated shaders. Okay, in other engines they're often called emissive shaders, and these are effectively shaders that we put on objects that cause them to emit light. All right, and so it's emissive light. So it's a type of light. It's not really a built-in light type, but it is light, so we're going to mention it now. We won't talk about self-illuminated shaders today, only because it gets a lot into shaders, and we haven't really talked about that too much yet. So it's just not really anything that's we're going to use a ton right now. We also have area lights. Area lights are basically a special type of light that emits a rectangular light over an area, and it's really, really intense in its performance impact, and as such we don't use, or area lights can't be used dynamically, so we can't place an area light and move it around and do all this stuff. Area lights are only for light mapping or baking, if you will, and so we don't really use those too much. Now, if you're wondering if we are going to get into light mapping, yes, we will talk about light mapping today. So yeah, we will talk about light mapping, so assuming we have enough time anyway. That's like the last topic on my list, so unless something goes really, really awry, we should definitely be able to get to that today. One other thing is, and someone mentioned this in the chat here, is light probes. Another honorable mention is light probes. Light probes we can talk about, but Not sure I'm really going to get into today, only because light probes are just a better way to calculate light. And so they themselves, without a lot of work, they themselves don't really do anything. And so I don't know that we would necessarily want to spend the time to set up a level with a bunch of light probes. I may in the future just do an entire session all about light probes, because there's a lot to know there, right? And so I really wouldn't be doing light probes and that sort of thing justice by covering it in a quick, like, 3-minute, by the way. And so I don't think we'll cover that today. But so those are our honorable mentions. Okay, so we've got things like self-illumination, or emissive shaders. We've got area lights, and we've got light probes. And we'll talk about the rest of this stuff. Those are our honorable mentions. Okay. So that being said, what is a light, right? What is this idea of a light in Unity? And a light is basically a component, just like camera was a component in anything else. There's nothing really special, okay, about lights themselves. They are just game objects. Okay, they're just game objects that happen to have a light component on them. As such, we can put that light component on anything, right? We can put it on spheres or cubes or whatever. So before we get into a lot of stuff, I'm gonna go ahead and set up kind of a basic scene, almost like a little jungle gym here, which is gonna let us play with our different lights and see the effects they have. So I'm gonna go ahead and I'm gonna have a plane here real quick, which I will put at 0, 1, 0, and rotate, I believe I want to rotate 270 to make it visible from my camera. There we go. Yep, 270. And then I'm going to go ahead and put in a cube, which I'll put at -2, 1, -2. And let me put in a sphere that I'm going to put at 2, 1, -2. There we go. So now we just have this kind of scene, right? So we've got a backdrop for light to be projected on. We've got a couple things to be dealt with. So yeah, so this, now we can begin kind of talking about this. So let's talk about the light component real quick. And with my sphere selected, I could always just come to like component and then go to, oh, I can never remember. Is it rendering? Yeah, rendering. Okay, component rendering. I never remember which menu it's in. Rendering and light, okay? And all of a sudden, the sphere becomes a light. It's a point light, okay? And I can put that on a cube. I can put that on the plane. I can put that wherever I want. It is worth noting, okay, that that putting a point light on a square object does not change it from being a circular light. If I were to put a point light on a plane, it would not illuminate as if the entire plane was illuminating light. A point light is circular, and so that is that. Now I'm getting a lot of questions already. I'm the only one from Unity today reading or doing this. There's no one helping me with the chat, so I kind of have to monitor the chat and talk at the same time. But let's see here real quick. How do you make an object stop a light from coming through? I'm not really sure what you mean by that. As far as, I mean, anything will block the light if I move around, you know. Obviously, a plane is only rendered on one side, so that wasn't very helpful. But basically, any object that the light falls upon will stop the light from progressing. So I think that's the question. If not, then yeah. Okay, so I don't really want to get too far ahead of myself here. So I just wanted to basically show you that we can turn anything into a light, and even though something is a light does not necessarily mean the light will conform to the shape of the object. A point light is an infinitely small point of light that emits in 360 degrees. So I put it on a plane, it would not illuminate like the entire plane was lit. It would still be just a single point. Okay, let me get rid of that. Remove component. Now, I also want to show you something else too. So if you remember before, let me hit Control Z. Oh, that's going to kind of spoil it, isn't it? So this is how it looked a second ago, right? Just like this. And then I added that light component, which I will put back on there. Okay, and this is what my scene looks like now. Now, when I go ahead and delete my light component, notice how everything is dark. Well, what happened, right? Everything was white, and we could move around and see it and stuff like that. But what happened? Okay, and so there's this button right up here. All right, it says toggles the built-in lighting on and off. When we add a light to a scene, it turns the built-in light off because we have a light now. We want to see things through that light. But when the light goes away, now everything is dark because the lighting is turned off. So to get things back to the way we remember them being, we just have to click this button and we come back to being lit like this. Okay, so that's what's happening there. If you're following along, you're like, man, everything is super dark. What happened? That's what happened. Okay, so yeah, so we can turn anything into a light, all right? But let's talk about the actual light objects themselves. Again, there's nothing special about them. They're just an empty game object that just happens to have the light component on it. But there's a few different ones, and so the light component is configured a few different ways by default. So what I'm going to do is I'm going to go ahead and create. I'm going to click create right here. You could also come up to game object, create other, but I'm just going to click create, and I'm going to select point light right here. And I get a point light added to my scene. Of course, it puts it back there. So I'm going to put it at, let's say, 0, 1, -5. There we go. So we have this point light, okay? And it is illuminating our scene. And if I come to the game mode here, we can see that's kind of what it looks like. So we get this point light. Now, that being said, the point light in dark situations can have some performance issues, and we could see some banding and stuff like that. You might be able to, I can't tell if you can see on your screen or not, whether or not, or if that you can see that there's some banding and some striations here with the light and stuff like that. I'll show you here in a little bit how to fix that, but for now, let's just talk about the light, okay? So we have this light object, and as we can see here, it is just an empty game object with a light component, and that's it. So let's talk about some of the properties of this light component, because they can make this light behave all sorts of different ways. So first off, we have this type. And by changing the type, we can actually change what type of light it is. So you might have noticed when I clicked create, I had options of directional light, point light, spotlight, and area light. Well, I can take any light and turn it into a directional, point, spot, or area. Okay, so if I created the wrong type of light, I don't need to delete it and create a new one. I can just change it with this little drop down here. Okay. Next, I have the range, and the range is how far the light extends. All right. So at the center of the light, our light intensity will be 100%. Okay, and then by the time we reach the end of our range, which we can see is denoted by this dome, all right, light will be 0, and it fades in and out appropriately. So if I were to move this back, we can see it gets darker and gets super bright and whatnot. So I can put it real close and make a really bright light or whatever. I'm going to put this back to where it was, which was -5. So the range allows us to make it bigger or smaller, right? So I can make it a really small light. Only things that are very close get affected by it. Or I can make it a huge light, right? Entirely up to me, however I want to light my scene. All right. Next, we have the color. And the color is obviously the type of light it is. So white light is what this is pouring out right now. White light is actually fairly rare, though. Like real white light is not so common, even in your everyday life, right? I mean, even if this was the sun tends to be just slightly yellow, right? Or if you're in a mine, you might have tungsten lights, right? Or you might have, oh, what do I want? Maybe some fluorescent lights, right? Slightly blue or whatever. So every light is a little bit different. And so we can emulate what type of lights we have by changing the color. I'm a fan of tungsten. Bam. I like that. Tungsten lights are super creepy. I like them. Next, we have the intensity. And the intensity is just that. Intensity is not range, it's how much power is being put out. So I can make this a really intense light. All right, something like this, really intense. You can see it really crank up there. It still will only extend to my total range. It will not go past 10, right? 10 units. It will not extend past this globe, but it will be very, very bright inside this globe. All right, and so I can change my intensity there. I think we started something like that. That's close enough. Next, we have this thing called a cookie, which we will talk about, but not just yet. Basically, a cookie is like if you've ever done light shadows or light puppets where you put your hand in front of a light and make a bunny face or dog face or whatever. We can do that with cookies, and I'll show you how to do that, but we'll come back to that one. Next, we have shadows. And for shadows, I'm going to go ahead and put my color back to the way it was, and I will set my intensity to 2. Now, shadows are a Unity Pro thing, okay? So Unity Free does not get non-baked shadows, okay? And we'll talk about that a little bit. And I'm trying to remember off the top of my head if light mapping is available in Free or Pro only. I can't quite remember, but I do know that shadows from point lights are not available in Free. They are available only in Pro. But since I have Pro, I'm going to show you. So first off, we have this no shadows selected, and as you can see, no shadows are emitted. All right. People are saying that it is free, or light mapping and baking is available in Free, and as of Unity 4.2, hard shadows with directional lights are also available in Free. So thank you very much. Joshua B. Dunn, Harry Godden, and Sindre Upshaw. I'm sorry if I mispronounced your names. Thank you very much for letting us know. Appreciate it. So right now we see that we have no shadows. And if I want to have a shadow with my point light, I can click the where it says no shadows, and I have a couple options. I have hard shadows, which are going to give me very crisp, hard lines. Or I can select soft shadows, where there's a little bit of blending between the shadow and the surface. So if I click hard shadows, you're going to see that shadows appear. Now, what I just did might be a little bit misleading, because if you're following along, and if you just did what I did, it didn't work. Okay, let me show you what happened. So I'm going to set this back to no shadows, and this is something I did earlier, and I meant to undo it, and I just now remembered that I didn't undo it. If you come into Edit, and then Project Settings, and then Player, alright, we get to our Player Project Settings, and you'll notice that my rendering path is set to Deferred Lighting. Well, everyone's by default is set to Forward, so I'm going to set this to Forward, where it should be. And I'm going to come back here, and now I'm going to select hard shadows. And I'm going to get this message: only directional lights have shadows in forward rendering. So if you're following along at home, that's what you saw, okay? Which is what I am now seeing, okay? And so I am, I'm like, oh man, I can't have shadows on a point light. Well, that's not true, but for efficiency's sake, point lights will not emit hard or soft shadows, or there will be no shadows calculated with forward rendering. So in order to show you shadows, I will now turn forward rendering off, and I will turn it into deferred. So again, if I want my point light to give me shadows, I'm going to come to Edit, Project Settings, Player, and since I'm working on the PC right now, or PC, Mac, or Linux, I'm going to click this button right here, and for rendering path, I'm going to change this to deferred lighting. You can also do vertex lit, which gives you lower fidelity in your shadows, but it's more efficient. So if you're building it for older computers, right? Some older computers can't even do deferred lighting. They can only do vertex lit. But since I'm not really worried about that, I'm going to choose deferred lighting. There we go. And I get my shadows. And you're also going to notice that this is a rather low light situation. We've got 1 point light, it's low intensity, so there's not going to be a ton of difference between soft and hard shadows. You can see it just kind of barely softens the edge, right? But that's it. That's really all it does. And it's because we're just kind of in this low light situation. It's why we also have this banding, because we're in this low light situation. So yeah, so anyway, so we can change our shadows. We can also change our shadow strength. All right, so I can make it just sort of a semi-shadow by reducing the strength of the shadow. Or I can increase the strength to make it a real hard shadow. It makes sense that this would be a very, very hard shadow of full strength, because this is the only light in my scene. There is no other lights, and so it's not really anything that, it looks realistic for these lights to be full strength. I can also change the resolution of these shadows, but I'm really just leaving it as use quality settings. If I wanted my light to be different from the quality settings of the rest of my scene or my game, I could do that, but that doesn't really make a lot of sense. It's a very specific case. And then we have this bias, right? And the bias, to be absolutely honest with you, I don't really know what it does. It doesn't ever seem to really change anything for me. I believe the bias is the shadow priority when there's multiple lights, but as it's something that I've never really touched, I couldn't honestly say. So, yeah. Obviously, not something that's super important. These next items here, we're not going to talk too much about. Well, we will, but we'll come back to them. So draw a halo. We'll talk about halos a little bit later. They're pretty neat. Flare. We actually looked at flares a little while ago when we did environment effects with the sun, but we'll revisit flares. Then we have render mode, and render mode switches between auto, important, and not important. So basically, we can have light set as important or not important. And what that effectively means is if the system needs to speed up or save on some efficiency, it can render lights that are far away from the player or the camera not as well, right? It can reduce the quality, right? And so we have this option of saying, hey, this light is important or this light is not important, right? I believe the example given on the documentation is the headlights of the player's car is a fairly important light. So we would set that to important, right? But like maybe a candle across a courtyard from the player might be not important. It's just one candle, whatever, right? If we want to let Unity decide, we can just leave it at auto, and it'll decide what's important and what's not important. All right. So yeah, we can change that. Just like what we saw with cameras, we have this culling mask. So we can choose for the light to not affect anything. Or we can choose for the light to only affect certain things. By default, light affects everything, but we have that choice. We can specify what we want our light to work on. Okay, then we have light mapping. And light mapping is something we're going to come back to, but basically we can do real-time only, baked only, or auto. This will make a little bit more sense when we talk about light mapping. For now, we're going to leave that at auto. Okay, and that basically just means we're going to let Unity, again, decide what it is we want to do with the light, whether it's light mapped or not, or dynamic or whatever. Okay. So that's our light, or that's our point light, if you will, which again, I can show you, you can move it in and out, you can see it affects the shadows, right? So it's real-time calculated. If I run the game, right, you can see the light is calculated, shadows are sent to the left and the right, because the point light is kind of in between them. Okay, so let me reset this. Just resetting the position there. Okay, so that's our point light, and we can kind of see the effect the point light has. Now, let's turn this into a spotlight. Now, a spotlight is like a flashlight, okay? It emits in a cone in one direction, all right? So, like headlights in a car, a flashlight, a theater spotlight, or whatever, are all kind of examples of this, all right? Now, the spotlight, again, just like the point light, will be affected by this total range. And you can see the intensity and the sharpness of that circle changes with how close you get. So if I'm real close, you can see as this gets further away, the edge kind of dulls and flattens and kind of disperses evenly. But if I bring this real close, we can see that edge gets real sharp. All right. So the spotlight allows us to kind of control the intensity of that edge based on the distance, right? It's real-time calculated there. All right. So now with the component properties of the spotlight is very similar to that of the point light, but we're still going to kind of go through them. So again, we have this range, and the range just determines, just like it would seem, how far out, right, this will extend, the power of the light, right, defaults to 10, put that back. Again, we have the color, I don't think I need to show you that. Again, the intensity, okay, intensity up and down, intensity is obviously how intense that light is. All right, and then we have a cookie, again, which we'll come back to. We have shadows. Now, right now, we're not seeing any shadows because the spotlight is in between these objects, but if I come across here, you can see that we will have light on the objects, and we can turn our shadows on. Well, that's weird. Shadow is not calculating. Do I have this set to something else? I'm not getting a shadow. Let's try hard shadows. Huh, not wanting to calculate shadows for me. Wonder if that's a bug or if I did something with my settings. At any rate, no shadow there. That's strange. but I might have changed something in my settings on accident. Yeah, not really all that important right now. But the shadow settings are all the same anyway. And then we have the draw halo, flare, render mode, calling mask, and light mapping. Again, not very different. All right. So let's look at one more. Let's look at the directional light. And the directional light, you'll see, boom, is very bright. Okay, very bright. And the directional light, as has been stated before, is treated as being an infinite amount of distance away where all the light is coming in parallel. As such, you will see that moving my light has absolutely no effect. All right, no effect whatsoever. And this is because the light pours evenly across the entire scene from an infinite distance away. The position of the light is irrelevant. The only thing we can do to make this light different is to rotate it. Rotating is the only thing that changes this light. All right, and let's turn shadows on with this. So we can do hard shadows, we can do soft shadows, it's kind of the same. With this type of lighting, you can see the shadow is pretty much lined up directly, all right, with the object itself, since the light is coming in from such a far distance away, and it's all parallel. So that we're not going to see any perspective parallaxing off to the left and the right, because that's just not how directional lights are calculated. I can move them, but they move evenly, right? And we could see some perspective distortion, but there's no way I can position this light so a shadow from the cube goes to the left and a shadow from the sphere goes to the right. It's just not calculated like that. All right. Now, as was pointed out in chat, directional lights in free work. Directional light shadows work in free. Directional lights happen to also be the only light where we can set our player settings to forward rendering and still have them work. All right, so we can see forward rendering, we still get shadows. Okay, let me change this back so we can do shadows with the other. So yeah, so we have some options with our settings and whatnot with directional lights. So directional lights, very powerful. You'll see that anytime I do like a landscape, like terrain, I put a directional light in as the sun, right? And really, anytime you have an outside scene, where you're going to have some sun figure or moon, right? You're going to be using a directional light. A spotlight just won't quite suffice because it would be really impossible to get the light far enough away with a big enough range to be calculated efficiently, right? So we basically use a directional light there. Okay, so directional light's cool. Basically every light kind of has its point. I will show you real quick here area, right? And area is basically, I'm going to turn the scene lighting back on. Area is basically this, where we get this rectangular area. And I can increase the width and I can increase the height, but you're not going to see it do anything. It's not calculated in real time. It's not emitting anything right now. It's not all that useful. But we will talk about this light when we get to light mapping or baking. That's where we use this light. Okay, we don't really use it right now. So one question from Pavel here is, can I use multiple direction lights with limited range or something? You cannot limit range on a directional light. You'll notice that there is no range option. There is, and let me turn that back on, there is the intensity, for sure, and let me set that back to 1. Yeah, but there is no range. Directional light is infinitely ranged, infinitely parallel, infinitely far away, like the sun. Okay, you know what? And now that you've asked the question, I've never put multiple direction lights in a scene. Yes, you can. You can have multiple direction lights, but you cannot change the range of those direction lights. As you can see here, I don't know why I'm moving that because it has no effect, but we can rotate it and we can see how the shadows are kind of calculated between the two. And actually, if I put shadows in this one too, we can get double shadows in there somewhere. There we go. Yeah, we could do multiple shadows and whatnot. But yeah, so we can have multiple direction lights. I've actually never tried that, but we cannot we cannot limit the range in any way or like that. Yeah. Okay. So that's our directional light. Fantastic. Let's talk about some of the other parts of lights that we haven't quite mentioned yet. So what I'm going to do is I'm going to come back to spotlight, or not spot, I'm sorry, point light, and I'm going to make sure that's a range of 10. Oh, that didn't work. Range of 10, there we go. Intensity of, we'll say 2. Okay, not 20, 2, there we go. Alright, so let's talk about halos real quick. Halos are a pretty neat means of having, what do I want to say? Means of having an effect to it, right? So let's say I have a light, a point light, and I want it to look like it's foggy out, or I want to look like there's a lot of dust in the environment, or I want to, I don't know, just give it some ambient effect. Maybe it's snowing, maybe it's foggy, or it's smoky, or whatever, right? If you've ever looked at a light, when there's a lot of fog or smoke or anything like that, you'll notice the light has sort of a halo around it. Or if you happen to live in the desert and you're outside and you look up at the sun and you notice the halo around the sun, that's the sun's light hitting dust in the atmosphere and causing a halo. Alright, so we can give our lights these halos, and there's a few different ways that we can modify them. So the simplest way to add a halo is just this draw halo checkbox. And then when I click this, I get a halo. Alright, it's a halo that appears around our light. Now, there was a bug with halos in a previous version. I think it was Unity 4.03 or maybe 4.1 or something like that. There was a bug with halos where clicking that would not cause them to show up, and you had to add a halo component and remove it before they would start to show up. So if you're having that issue, you can add a halo component, which I'll talk about here next, and that'll fix it. So it was just a bug. But yeah, it's fixed now in the new versions of Unity, so it's not anything we have to worry about. Another thing you might notice, this happened to me the first time I ever tried to use halos. I had my light, I was looking at my light, and I turned on draw halo, and nothing happened. As you can see here, nothing happened. And I was sitting there thinking, why aren't halos working? I thought I had a bug. I thought this was the other bug. I was trying to add components, remove them, and nothing was working. And if you're in this situation, I can assure you it's working. You just got to back up. That was the problem. I spent hours and hours and hours the first time I ever tried to get a halo working, because I was like, man, this is just not working. What is going on? And it turns out you just got to stand further away to see the halo. So if you're having this issue, that's what's happening. You can't stand real close, or else the halo will not be visible. Yeah. So yeah, lesson learned, and I'm passing that on to you. So you might be wondering, how do we know how big this halo is going to be? I mean, that is a really big halo, right? Well, we can control our default halos. And so what I'm going to do is I'm going to come up here to Edit, and I'm going to come to Render Settings. My render settings appear here, and I have these two options, or this one option, I'm sorry, halo strength, 0.5. And what that means is that since my light is 10 units, all right, my halo is going to be 5 units because it's 0.5. All right, I can make it 0.1, so if it's 10 units, my halo will be 1 unit, so on and so forth. This is a global setting. This affects all halos in the scene. Alright, so if we have a bunch of halos, this is going to affect all of them. So keep that in mind, that if you only want to affect one halo and not the rest of them, this is not the right place to change it. Okay, but anyway, so that's how we control the strength of the halo. It is 0.5 of the total range of our point light. Okay. By the way, we can have halos on any type of light. Yeah, even directional lights. Yep. So halos are halos. You can put them on anything. Okay. And so let's look at the other way to use halos. Okay, so let's say I wanted a very special halo only on this light. This light right now, the color of the halo is chosen by the color, and the strength is chosen by my environment, or by my render settings. And so let's say I want this to be a very special halo. Maybe I want the light to be a white light, but I want an orange halo, right? Or I want to change its size without changing all the rest of them. To do that, I'm going to uncheck this draw halo. I'm not going to use a default halo. And I am going to instead, by the way, real quick here, someone said, how can we chat with Mike? Ahmad Windows 8, hello. Any of the chat rooms, either the Twitch chat or Chatroll, which is hosted on the Unity 3D site, just write it in there, and I will see it. Also, if you rewatch the video, I plug my Twitter handle. I'm not going to do that right now, but yeah, if you want to chat, there you go. Sorry, I kind of saw that, and now I've lost track. Oh yeah, so if we want to add a halo another way, so we can add a halo component. So we're going to go to Add Component, Effects, Halo. And I'm glad I remembered on the first time. I wasn't sure if it was in the effects menu or not. So we're going to add a halo component. Now this halo is a specialized component. It looks the same. However, we can control its size independently of the rest of the halos in the scene. Right? We can even make the halo even bigger than the total range of the light. We can do whatever we want with it. All right? It's a halo that's its own special component. We can also change the color of the halo. And you'll notice, so if I make it bright red, we got a bright red halo, yet it's still a white light being projected on the plane and the cube and the sphere. So in this manner, we can make a specialized halo which has its own specialized color and size, which is not related in any way to the color of the light or the size defined by our render settings. All right. So 2 ways that we can have halos. Now, if you're having the bug that I was telling you about, where, and you can have 2 halos by the way, the bug where clicking draw halo was not giving you an actual halo, if you add the component and then immediately remove the component, all right, then this magically works. It was a bug in an older version of Unity. It doesn't exist anymore. It's not a bug that's a problem anymore. So you shouldn't have that problem. If you're having that problem, just update, and it will get rid of that problem. Okay. So that is halos. All right. Let's see here. I got a question here. Sometimes when I make a point light, it goes through the box mesh, even if I make the box mesh receive shadows. Any idea why this is happening? Yeah, so your point light can only give you shadows if you change your project player settings to be deferred lighting as opposed to forward lighting. Forward lighting point lights do not cast shadows. Hopefully that was your problem. If not, maybe we can chat later. Okay, yeah, so we can fix that. Real quick here, and this is something that I just remembered. I mentioned it before. I kind of teased you guys with it. This banding problem. Remember I told you about this banding problem? If I come over here to game mode and you see this banding with a point light, okay, we got some pixelation, striations, banding, whatever. It looks low quality, and you might be thinking, man, that looks kind of ugly. Well, what we can do actually to fix that is if you click on the camera, and I actually talked about this before when we talked about cameras in a previous session, but I'll talk about it again now because I only talked about it briefly then. If we click HDR, hyperdynamic range, all right, and then relook at our scene, we'll notice that that banding is gone. All right, it's much smoother, much higher quality, stuff like that. So yeah, so basically that's kind of the fix there, is to use the HDR. Which is easy to use in real simple scenes like this. HDR is much harder to use when we've got a lot of like high quality meshes and stuff like that, and then we have to get into UV mapping and light mapping and stuff like that. But basically, that's how we can fix that banding problem, is in our camera, just turn on the HDR and it fixes that banding problem. Okay, so that was just kind of your quick tip for the day, in case I just wanted to say it there, in case I forgot it, because I forgot it previously and I didn't want to keep forgetting it. Alright, so those are our halos. Let's look at flares real quick. Flares are something that we've seen before. It's nothing new. So we'll do it real quick here. A flare is, so with my light selected, you can see here that I have this, where is it? Flare. And I see none, and if I click this little circle, I don't have any flares in my scene. So let's go ahead and grab the standard flares. Some flares are built into Unity for us. I'm going to come to Assets, Import Package, Light Flares. I'm going to get this little menu right here, and then I'm just going to click import, and that's going to bring in, I believe, 3 flares. And so let's see, with my light selected now, I'm going to click flare, the circle next to flares, and I can see that I have 50mm zoom, small flare, and sun. We've seen sun before. I'm going to wow you right now with 50mm zoom. This is a heck of a flare. Bam! Alright, so behold the glory of the 50mm light flare. And you can see we've got some nice lensing effects and stuff like that, and some just crazy amounts of vertical distortion with the light and stuff like that. But there you go. It's kind of like you're using Photoshop and you're just putting lens flares on everything. That is a heck of an effect. Yeah, and when you go into game mode and it's so beautiful, it's so brilliant. But anyway, that's our big flare. Let me reset this back to where I'm supposed to be because I moved it around so much. Let's try a different flare, one that's maybe a little bit more subtle. Sun is a pretty subtle flare. Oh, maybe sun is not a subtle flare. Small, there we go. Small is a subtle flare, which obviously is just this real tiny little thing there, and you click on it, you can see a nice little small light flare. We can also come into edit, again, render settings, and flare strength, and we can reduce the power of flares. It goes between 0 and 1, 1 being 100%. We can kind of reduce the strength of our flares there. Alright. Speaking of which, I forgot what I mentioned while I was here. We can change our halo texture right here. We can give our lights different halos, which is cool if we have something very specific in mind. Like we can give it flares as a halo and whatnot. However, the default one is just the basic like particle, round, circle, whatever. So if we wanted, we could change it here. I forgot to mention that when we were here earlier. Okay. So let's go ahead and get rid of this flare. It's pretty obnoxious. But you can do, I mean, if you think about it, lens flares add realism if you're trying to emulate an environment where a camera is used, right? Because that's what lens flares come from, right? If you don't look at the sun and see a lens flare, but if you took a video camera and recorded the sun, you would see a lens flare. By the way, Surgeon General's warning, don't look at the sun, right, directly. I shouldn't have to tell you that, but just in case you're like, hey, the guy from Unity said I can stare at the sun, and you blind yourself, I'm not telling you to stare at the sun, so don't stare at the sun. Correct. So Harry Godden stated that you can add custom flares too. That's absolutely correct. You can create your own flares. There's no reason you can't. Okay, so that's kind of your flares. They're real simple to use, but yeah, they can have a neat effect in a specific situation. I'm not a fan of flares. I think some people just really overdo it, and all of a sudden you got flares like everywhere, and I don't think that's all that effective. All right, so now let's talk about cookies. Cookies are probably like my favorite part of lights. I am like a big fan of whoever came up with the terminology with lights, because we have light cookies and we have light baking, and both of those sound delicious. Someone needs to invent like light cake or something like that, or maybe pie. But I love the terminology that we get with lights. So we're going to talk about light cookies, which is my favorite. Yeah, light cookies are actually really, really cool. They effectively allow us to project something onto the screen or in the light. So if you're a fan of, if you all know of Batman, right? The bat signal, right? Is that big bat symbol that's projected into the sky from a giant spotlight. That's a cookie. Or if I were to have a directional light inside a metal frame, and say like a dungeon or something, and that metal frame had ivy leaves on it or something, I could project the ivy leaves out as a cookie, or any symbol really. And I'm going to show you how to do this. And you can get like special cookies that are made to be cookies, or you can use pretty much any black and white image, right? Which is kind of neat. So we can use any black or white texture, and we're going to go ahead and create a cookie out of it. So for this, we're going to go ahead and use the Unity logo, which I'll project up here. Hopefully you can see that. That is the Unity logo we'll be using. You will see that it is a black and white picture. And with this, basically, black will block all the light, and white will let light through with a black and white image. All right. So basically, we get to basically put a cap over our light and determine how the light filters through. So white is going to let light through, black will not, and so we can effectively block light. Okay, so what I'm going to do is I have this in this little folder here, this logo PNG, and it's a PNG. I could use, I think, a JPEG or a GIF or a BMP. I don't think I can use a GIF. I don't remember. Just use a PNG. It's a high quality. Who cares? Yeah, but anyway, that's I don't know. I always just use PNGs. That's my little spiel. If you have another file format, more than likely it'll work. I don't really remember all the file formats that are allowed, but I use PNGs. Another thing too is that this texture, I am specifically using one that is 512 by 512. More importantly, that is a power of 2. Okay, so it could have been 256, 256, 128, 128, 512, 128, whatever. It doesn't have to be a power of 2, but man, it it increases efficiency, it reduces artifacts, and when we create our maps, it's going to prevent all sorts of wackiness from happening. So if you have control over the size of your texture, make it a power of 2, and you're going to save yourself a ton of problems. All right. Okay. So before we can just use this as a cookie, right? And actually, let's take a look. I think if I just grab the logo, it's not going to do what I want. Yeah, it doesn't do what I want. It does, yeah. Okay, I just wanted to verify that it's not doing what I want. We can't just use this as it is, because as it is, it's a texture. It is a picture, and we want to turn it into something different. Okay, and so what we're gonna do is we're gonna build this texture into a cookie for a light map, or for a point light. Now the cookies are different for each type of light, and I'm going to walk you through how to make a cookie for each type of light. And like I said before, if you happen to have like a cookie file, one that's made to be a cookie, go for it. You know, but I'm showing you how to do this with just a flat image that's not made to be a cookie, how to kind of create your own. So with logo selected, in the inspector view, I get all these texture options, okay? And what I'm going to do is I'm going to set this up to be a cookie for point light. So what I'm going to do under texture type, I'm going to change this to be advanced, all right? Now don't get caught up in clicking cookie or light map or any of these other ones. I've used the cookie option to some effect, all right? But I've never quite gotten it to work the way I want it to. So I always just go to advanced. Do what you want, play around with the other one if you want, but I always go to advanced. From here, with advanced selected, I can leave all this stuff kind of the same. However, for generate cube map, I want to select full cube map. Now, since this is a point light, it emits light in every direction, right? So we need a cube map that sits around the light and tells it how the light's being projected in every direction, right? So we want to do full cube map. I also want to choose alpha from grayscale. This is how we take a black and white image and turn it into a light versus darkness image. So that's important. Alpha from grayscale. All right. And then we want to leave generate bitmap selected and just choose border bitmaps. And then finally our wrap mode needs to be clamp. Okay. And with these settings, and you can obviously rewatch this video later or take notes or whatever. And just remember, that's how it goes. And I'm going to hit apply. And you're going to see my texture now turns into this cube. Okay, it's a cube map. And then I'm going to click on my light, and for a cookie, I'm going to select my logo. And boom, there we go. We have a cookie. And we can see how the cookie gets projected in every direction, right? Because this is a point light, so it's emitting all over the place. So if I bring it real close, we can see that the cookie is emitted, in fact, in all directions. I had a question, what does MIP map mean? It's actually MIP, M-I-P, MIP map. MIP mapping is basically how a texture is expanded or condensed. So if I have a 256 texture, right, so 256 pixels by 256, when I generate my MIP maps, it will create a 16 by 16, 32 by 32, 64 by 64, 128 by 128, 512 by, or 512, 1024, 24. So the MIP maps is the algorithmic scaling up and scaling down of our textures. So that when I'm real close, we can use a high resolution texture. When I'm far away, we can use a low resolution texture, and MIP maps are just the generated textures. So there, hope that answered your question. So we tell it to generate these so that we can increase our quality. And so there we go. So now we have our light. And also neat is you can see that the bitmap, I'm sorry, not the bitmap, the cookie is actually projected onto the cube and the sphere, and it's leaving a shadow of the right shape. Also kind of cool is check this out. I'm going to go ahead and duplicate this plane, and I'm going to move it up. Kind of up here, and then I'm going to rotate it down. Let me move this in like this. Okay, so now we have this plane up here. All right, and let me increase the range of this light. We'll increase the range and the intensity a little bit, which will really kind of drive home the effect. And you will notice that there's distortion on the light, so it actually distorts as it moves further away, just like real light would. So it's actually a pretty neat effect, right? So we get this distortion, we get this projection and whatnot. We have a couple questions here. Can we use a video as a cookie? I don't believe so. I believe because it's not actually a texture at that point. It gets kind of converted. So I'm not really sure. Maybe I'm not understanding the question. Can the light cookie be like a projector too? Yep, we'll talk about that. And I also wondered if it can be something animated. So I'm not sure what you're asking, but we can move this stuff around in real time. It's calculated. And I'm not sure if that's what you're asking or not, but we can certainly do that. Okay, so anyway, that is. Let me change this back to the way it was, change our intensity back down to 2, and change our position, 0, 1, -5. Yeah, so that's point light, and basically we emit the cookie in every direction. All right, and we can put kind of whatever we want there. And so now let's talk about using a cookie with a different type of light. Let's talk about a spotlight. So when I click spot, you'll notice the cookie is cleared out because we can't use a cookie that was made for a point light on a spotlight, because a point light needs a cube map and a spotlight does not. So let's look at the settings for that. So I'm going to come over here to logo, and all I really need to do is change full cube map to none. That's it. Generate cube map just goes from full cube map to none. I hit apply, come back to my spotlight, look for my cookie, and there it is, and there we go. We get it projected. And this is kind of like your Batman logo on the night sky, right? So pretty neat there. And of course I can change my range, and I can change this. Oh, you know, I didn't even mention the spot angle when I talked about spotlights. I'm sorry. The spot angle increases the cone of the light. Yeah, I can't even believe I forgot to mention that. Skipped right over it. But spot angle, cone of light. And I can rotate this, and you can see it's just like a spotlight or like a flashlight or anything like that. If you put, if you use tape and put tape on the front of the flashlight and then show the flashlight, you would see that a symbol gets projected, or whatever you drew with the tape gets projected. All right, so we can do that. Cool. We can also do these lights for directional lights. So let me reset this again. I like to reset everything back to my defaults before I start. Let's switch this over to a directional light. Oops, directional light. There we go. And so the distance won't matter there. And now let's come over here to logo, and we just need to change one more thing. We are going to go to wrap mode and change from clamp to repeat, and hit apply. So wrap mode goes to repeat. I click on my light, I click on my cookie, I click logo, and there we go. And it just repeats. We have to do it that way. I guess we don't really have to, but we do it that way because the light mode is infinitely far away, infinitely parallel, and whatnot. And so you're gonna want it to repeat, obviously, or else it's gonna affect just a very small centralized region, and that's not gonna make any sense. So. Some questions real quick here. I'm trying to keep up with everything. Mike, why don't I read the other chat? I don't know. I didn't see your question. Ask me a specific question. Some people are saying I don't understand. Ask me a specific question. I will answer it. Otherwise, I'm not entirely certain what the question is. One question here: can we make a cookie smaller? It depends on the type of the light we're using. So a directional light, as we see here, its position doesn't really matter, though we can see that we wrap it, right, so that we can have multiple versions of it, which only makes sense for a light, a directional light. Reset there. Otherwise, we can zoom in and out to change the size of the cookie, but the cookie is expanded to be the full size of the light. So there's no changing the size without just changing the light. They don't really work independently like that. That's why we generate the bitmap. So if the light gets bigger, we get a bigger cookie. If the light gets smaller, we get a smaller cookie. Oh, well, with directional lights, I'm sorry. With directional lights, we can change the cookie size. Just like that. I forgot in directional lights we could do that. But with point lights and spotlights, changing the size of the cookie is changing the size of the light. Directional lights are a little bit different, so we get a choice there. Sorry about that. All right, it's difficult trying to keep up with all of the writing and whatnot. Okay. Yes, you can watch this later. It is being recorded and will be available on our YouTube channel and our website, so on the archive. And I will link to that when we get to the end here. Okay, so that's cookies. We can do a lot of cool stuff with cookies. I'm a big fan. I think they're really neat, especially when we start working with spotlights, or not spotlights, I'm sorry, point lights. And obviously the cookie is not going to work for this, and we get into the cube mapping. We can do some really cool stuff there. Now, what time is it? Okay. I have one more topic. I'm going to kind of get through it a little bit quickly because we're kind of running out of time. I like to keep this about an hour, and we're about there. So let's talk about light mapping. Light mapping is basically where we can do all of the calculations of our light and then not have to do it in real time. So basically, right now, all this light is being calculated in real time. Okay, and so every single frame it calculates all this light, looks for things that have changed and all that. And that's very cumbersome. It's a very cumbersome procedure, especially if you have a lot of lights and a lot of movement and whatnot. So what light mapping allows us to do is say, hey, these objects here aren't going to move. They're going to stay right here, and they're not changing at all. And so you don't need to recalculate this light all the time. Okay, and what it does is it builds for us a light map, otherwise known as baking. Okay, and so, and honestly, there's a couple of ways we can do baking. The real simple, like the poor man's version of baking, the real simple way to do baking, is if I were to say make a texture for this plane and actually put in, like, say, Photoshop or Paint or GIMP or whatever, put these black shadows here. Right? Then the texture itself will have that shadow. And that's a real simple, real kind of cheating way of baking shadows into a scene. Now, if you don't want to do that, we can actually bake them using Unity. All right. So let's say that I know these planes and this sphere and this cube are not going to move, nor will this light. They will always be there as the game is being played. The player's running around, but these things are static. Think about it as like the street and buildings and a light post. All right? Well, the light post isn't moving. It's anchored into the concrete. And the street and the buildings aren't going anywhere either. Right? Those are fixed things. They will not change. So what we can do is we can improve our efficiency by baking them. Okay? So that they stay this way. So what I can do is I'm just going to find some lighting that I like. I'm going to kind of maybe... I'll do that, whatever. And so let's say this is good, and I want to leave this like this permanently. I want to bake this. All right. What I want to do is, first off, I need to make sure these objects that aren't going to be moving anymore are set as static for light mapping. And so what I'm going to do is I'm going to click on each one while holding the Control key, Command if you're on a Mac. And so all four are selected. I'll know they're all four selected by looking in the hierarchy window right here. All right. And then what I'm going to do is I'm going to come up here to the inspector, and I'm going to hit the drop down next to static, and I'm going to choose light map static. That basically means these are static for the purposes of calculating light maps. If I don't do this step, light mapping is not going to work. So I'm going to click light map static. All right, just like that, and now they're light map static. And now the last thing I'm going to need to do is I'm going to need to open the light mapping window. It's not open by default. So I'm going to come to Window and Light Mapping. And it's going to get me this window here. And of course I can dock this window in anywhere I want, but I'm just going to leave it open right here. In the Option tab, I can see that where basically everything is selected. I can see that I am using a plane and 3 others, which makes sense since I've selected 4. All right. I can do some things like I can change the scaling and atlasing and stuff like that. I'm going to leave that the way it is. Next I have Bake. And I have a couple options. I have single light maps, dual light maps, and directional light maps. All right. Single light maps are basically one single light map, which is great if I'm not doing specular mapping or normal mapping, or I don't have a lot of dynamic lights. If I basically want the maximum efficiency, maximum speed, single light maps is the way to go. That being said, I can get a lot of quality out of dual light maps. And dual light maps effectively allow me to have 2 light maps, which will allow me to do normal mapping, will allow me to do UV map, or not UV mapping, I'm sorry, specular mapping, allows me to have dynamic lights and stuff like that, and they'll all be blended together. And so dual mapping is where you'll get a little bit higher quality. And a matter of fact, if I want to change the quality of my light map to low, dual light maps will still allow me to have a better quality than just a single light map. So one of the questions is, can I move an object after I selected light map static? Yes, you can, but it's not going to look right because your light will have been calculated off of where it was. So it will, yeah, it will leave a shadow behind. So basically, yeah, we can still move our objects. We may want to like lock them into place so we can't accidentally do that. However, we basically declare them as static so that the light maps will be able to do their calculations. As someone mentioned before, and I'm going to mention too here, the light mapping system in Unity is called Beast. So there you go. If you're doing any research in Unity or whatnot, it's called the Beast lighting system, and that's what it's called. So there you go. Anyway, so I'm going to choose dual light map. Well, I could choose single or dual. It doesn't really matter. I'm just going to leave it at dual. And what I'm going to do is, I have some options here. I'm going to go through a few of them quickly, some of the more important ones. Some of them I'm just going to ignore. So the first is bounces. So when a light comes in from a light source, so say this point light, and it hits, say this sphere, it's going to bounce and hit something else one time. All right? I can set it so it doesn't bounce at all. 0 bounces. I can set it so we get 2 bounces. Or if I want really reflective scenes, I can set it to 4 bounces or whatever, but by default it's 1. 1 bounce should be enough, unless I want things to like really bleed. So I want a light to hit a red object and then bleed red light onto something else. I'd increase the number of bytes, okay, or bounces. We can change our sky color and our sky intensity, which kind of flavors the light a little bit if I'm doing a terrain lighting. Bounce boost is I can make the light diminish after it bounces, so maybe be half as bright, or I can do something weird and increase the brightness or whatever, but this is basically just set at 1. We can change our contrast and interpolation, but I'm not going to mess around with a lot of this, and I don't really want to get into what a lot of this stuff does because it's not really important for us right now. So what I want to do is now I'm just going to go ahead and click Bake Scene, and I can do Bake Scene, Bake Selected, or Bake Probes if I'm using light modes. Or light probes. I'm going to use Bake Scene. And I am going to just click that, and it's going to make me save my scene in one moment here. Sorry, I had to remove someone from chat for swearing profusely and being kind of annoying. So please don't swear in the chat. I appreciate it. Okay, so I have to save my scene. So let me do that here real quick. Save scene, assets. I'm just gonna call it lights. There we go. Lights is selected there. And now we can see down here it's gonna say baking texture in the lower right hand corner. So this is gonna take a second. And it's calculating. Great. Now our light is baked. I'm gonna say, hey, it doesn't look any different. And you're right, it doesn't look any different. So let me just delete. Oh, hey, what the heck? That wasn't supposed to happen. I baked you, I thought. Let me rebake this. Maybe I click something. When I should be able to remove my light once it's baked, and the lighting should all still be there. So maybe when I clicked away and clicked back or something like that. Let me fix this. Oh, I gotta select all my objects. They're all set to static. I did something there. Whoops. I hate when that happens. It always happens when I'm live too. Bake. Let's go. Let me just try single light maps. Everything should be fine. I did this dual earlier. Bake scene. Alright, calculate it. It's baking. There we go. Now I should be able to get rid of this. There we go. I must have not done something there previously, so I apologize. I hate when that happens, when you're like, this is going to work, and then it doesn't. So you'll notice I deleted my light. I have no more light in the scene, yet I have light in my scene. Well, I don't really. What I have is a light map applied to the objects that I selected in my scene. So now I'm getting the benefit of lighting and shadows without having a light anywhere in my scene. Okay, so highly efficient, okay, because it's not calculating anything. It's just baked on there. And so, you know, you can see I can run my game and everything. And here's, I can add another point light. And let me set it back to 0, 1, -5. And you can see now it's going to blend, right, with the light that was already there. I'll set this to hard shadows. You can see, so now where it's effectively blending the light map versus the light created by the point light. We're getting two shadows, and they can overlap and whatnot. And my settings were a little bit different, so I can't get them to quite line up. But yeah, so we've effectively light mapped our scene. And we can get rid of the light mapping. Click our objects, come to window, light mapping, and we can clear the light map. And we go back to just the dynamic lighting and whatever. I'm gonna go back to dual light maps. Maybe that's what caused it to not work correctly. Let me bake it here real quick and see. Because I should be able to like move stuff around and everything without any real issues. No, that's not working. Okay, so I don't know. My dual light map foo is not working right now. But I must be, with this auto, it must not be remembering the settings or whatever. But anyway, that's light mapping. So sorry that kind of went on a fizzle there trying to show you dual light mapping. But like I said before, I'd really like to do a full session all about light probes and light mapping, right? Because you just can't really do it justice in the few minutes that we have here. There's just so much to it. And as you saw right there, I didn't get my dual light maps working, but we effectively do it with directional lights and whatnot. While I'm here, though, I am kind of over time, but one last thing I want to show you is we'll come back to this area light that I talked about before, right? An area light didn't seem to do anything, right? We can see that it's not illuminating anything, except if I were to bake a light map. So the area light's not giving us any light that we can see. However, I'll go to light mapping, single light map, bake scene. We'll clear first and then bake scene. And we are going to see that the area light is creating light in our scene just like that. Now our shadows aren't fantastic, right? Area lights aren't used to create awesome shadows. They're just used to illuminate large scenes, all right? So the area light was just used to bake that light, and then we can get rid of it. Kind of what we want to use the area lights for is we can put them on windows and stuff if we want gentle ambient light to come in through the windows. We put them on windows, we'd turn the intensity down, and they just kind of pour some uniform light out of them, right, for baking and whatnot. We can't use them in real time. So yeah, something emissive textures will also show up in light maps. That's actually absolutely correct. Self-illuminated textures, emissive textures we use, or not. They're not emissive texture. They're emissive materials and shaders will show up in light mapping. That's actually what they're for. We can't do real-time emissive textures, or I'm sorry, materials. We do light mapped emissives. Okay, so that is going to wrap it up for today. I went over and I got a bit rambly. I do apologize for that. I was trying to monitor chat, and we actually had a lot more chat traffic today than usual, so I'm sorry. I was trying to keep up with all of that. So the things we talked about the basic light types, point, spot, directional. We talked about self-illuminated emissive materials, area lights, light probes. I would like to do a session on light probes specifically, because I did kind of breeze over them, but they're awesome. So I would like to cover them more thoroughly. Also, Wednesday will be the next one, Fun with Lasers. It's more of an intermediate lesson, so be sure to know a little bit of coding, or at least know how to open mono development, things like that. That will be at noon Eastern time. Just check out the live page unity.com/learn for our live lessons. You'll also find our archives and stuff there. I didn't. You guys interrupted me. I couldn't finish talking about what we talked about today. We talked about the light component. We talked about halos, flares, cookies, and light baking. Real quick, any questions, comments, concerns? You can reach us on Twitter at Unity3D, at Mike Geig, which is me, at Will Goldstone, and at The Ant Ranch. Digga likes my beard. Thank you, Digga. I appreciate that. I like my beard a lot as well. So any questions, comments, or anything like that, feel free to message us. Again, sorry kind of for the rambly, but we will get to shoot some teddy bears with rainbow colored lasers on Wednesday if you're able to log in for that. So always a good time. Feel free to check it out. With that, we are finished for today, so thank you for sticking around. Sorry I went a little bit over, and have a fantastic rest of your day wherever you're at in the world, and hopefully I will see you on Wednesday.